Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, as always, Ricardo Lopes, and today I'm joined by Dr. Adina Roskies. He is the Hellman Family Distinguished Professor at Dartmouth College. Her research interests lie at the intersection of philosophy and neuroscience and include philosophy of mind, philosophy of science, and ethics. And today we're going to focus mostly on neuroimaging, a little bit bioethics, and let's see if we can get into other topics as well. So Dr. Roskies, welcome to the show. It's a huge pleasure to everyone.
Nice to be here. Thanks for the invitation.
So I would like to start with the neuroscience part of your work, and more specifically talk about neuroimaging, because of course I've had other guests on the show with whom I talked about this topic or addressed this issue. When it comes to neuroimaging, there seems to be lots of discussion out there about exactly what information we can take from it and what we can learn from it and its limitations, and some people even call some conclusions that people take from neuroimaging studies neurobollocks and stuff like that. So yeah, so I mean, just to start off with, what can we really learn through neuroimaging studies?
So that's a very general question. I think one thing that we learn is what parts of the brain are involved in processing what sorts of tasks. But that's a very general thing. And as many people have pointed out, they don't really care where things are happening. They want to know how things are happening. And so getting from where things are happening to how things are happening is challenging. But there are all kinds of techniques now and experimental paradigms that try to pull those things apart by making the general assumption that there's some kind of mapping between the structure of the brain and the function of the brain. And depending on how close that mapping is, I think something like neuroimaging can give you more or less insight into how things are happening. So one thing that we don't know is exactly how close that mapping is, right? So it's one of these scientific bootstrapping projects where you have to sort of, as you go along, figure out to what extent that assumption is true as you're trying to learn things about brain function. So I think it needs to be said right at the outset that imaging by itself is not very powerful, but we never do science. We never really use scientific techniques by themselves. We combine what we know from those techniques with what we know from other techniques, and that is a way that you can start getting at this kind of problem. So, we do know various things, like the brain is not equipotential, and that there, if you destroy certain parts of the brain, you interrupt certain kinds of processes. So we have good evidence that not everything is happening everywhere all the time. And we also have a lot of evidence that the brain has some kinds of specialized functions. But when I say specialized, I don't mean that they only do a single thing. There's still, I think there are still some people who think that once we get down to the totally fine-grained level, maybe we'll still find that sort of thing. But I think most people think that there are brain regions and brain circuits that are involved in multiple kinds of processing. So, I think many things require individual consideration. I don't think there's sort of a blanket picture of the right way to investigate the structure-function relationships, or any general claim that you can make that's true of every, all parts of the brain. But as research progresses with imaging, as well as with lots of other more invasive scientific techniques, we can start pulling apart some of these aspects of function. But I think that it's it's a difficult and challenging scientific problem, and it's not the sort of thing that you can just look at a brain scan and then read off what's going on. But I don't think that any serious scientist has thought that that's the case in quite a while, at least.
Mm-hmm. Yeah, there are very many different questions here that we could address, and I mean, some of them also connect to how we read neuro images, let's say, the kind of information we can get from that, what it really means for a particular brain area to be activated when people are performing a certain task or exhibit some sort of behavior, and even things related to specialization and the idea of modularity and all of that. But I mean, really, when we have, for example, a picture, because these are the pictures that make it to the media more often, I guess, neuroimaging pictures from a functional MRI. I mean, what can we really tell from that? Let's say that people are studying a particular behavior, people do something, or they are exposed to something, and then a particular area of the brain lights up in the images. So, I mean, is there... Of course, this is also, I understand that this is sort of also a general question. We would probably have to get into specific examples, but just from a picture of brain areas being activated, what can we really learn from that when it comes to brain functioning and also questions related to causality? Because there are sometimes claims that, because that brain area gets activated, that's what causes a particular behavior, for example.
Right. So, good. So one thing to be said is that imaging, the kind of information that you get from imaging is not causal information. It's correlations between tasks and activity. And so without other kinds of experiments that are interventional, it's very difficult to make causal claims. And so you might see activity in a place that's not actually really involved in the behavior, but just associated with or a consequence of the behavior that you're looking at. So I think that's something that imagers are very aware of, and they don't tend to make that mistake at this point. So the other thing that I want to say is the question itself is, I think, misformulated, although it's indicative of a misunderstanding that a lot of people have. And so the scientific conclusions that imagers make are not based on the pictures, they're based on the data underlying the generation of those pictures. So you can make a picture look very many ways. Images are not like photographs of the brain. I've written about that. Because the translation from the data to the image is something that requires a lot of decision-making on the part of the person who's making the image.
It's basically a statistical compound of the data collected from brain activity, something like that.
That's right. That's right. And you can choose your statistical cutoffs in many ways, and you choose your colors in ways, and there's all kinds of analysis techniques that you need to make choices about in order to generate a picture. But underlying that picture is a bunch of data, and that's what people are actually analyzing in order to come to conclusions about brain activity. So I think it's mistaken to think that the conclusions that scientists are coming to are they're coming to on the basis of the pictures. It is true that often the kinds of insights that you get are generated by or affected by the way in which you visualize the data. So, but then you have to go back and then look at the data and see whether that actually supports your hypothesis and whether it's statistically significant. So the pictures play a role in the process of, thinking about what the results mean, but they don't actually lead to the results, right? It's the underlying numbers, percent change, et cetera, in the MR signal is what generates the scientific conclusions, and it also can generate the pictures, but you don't work from the pictures, you work from the data.
Mm-hmm. But focusing on the data then, let's say that we're studying a particular behavior. So if we have knowledge from, let's say, for example, psychology, sociology, other areas of human that study human behavior like that, and we can also add to that perhaps neuroendocrinology and genetics. So if we have all of that kind of information, what would neuroimaging add to that knowledge that we probably couldn't get even with the combination of the information coming from all of those different areas of the study of human behavior?
So I tend to think that the best imaging studies are studies that are done with potential models in mind. And so if you have hypotheses about what areas are involved in what kinds of processes, and you have a task and you have hypotheses about what processes are involved in that task, you can see whether one model fits the data better than another model. You can also ask questions about whether there is information in the signal sufficient to support certain kinds of processes. So if you can decode from the signal that there is information that allows you to make certain kinds of predictions, then that information is there, but you still don't know if that information is actually being used by the brain. So I think that the kinds of claims that you can make from neuroimaging tend to be quite subtle and limited and provisional, because, as I said, they're correlation claims, they're not causation claims. But you can then test those claims using other methods. People use TMS. In animals, you can often do more invasive kinds of recordings to corroborate your theories. So I think of imaging as a tool, one of many tools that neuroscientists use, but it's a tool for constructing and testing theories, but it's not sort of the last word on whether these theories are correct. Another thing that it can do is suggest places to look with other tools. So if you're interested in some kind of task and you can see what brain areas are activated by that task, that gives you a target for further studies. If you're going to do things, some kind of interventional task or look at what's happening at the single cell level, you don't want to be fishing around without any hypotheses about, where in this big brain you should be. But if you have information from neuroimaging, that can tell you where you should start looking.
Mm-hmm. But in doing all of that, and of course, going back again to the question surrounding these being the images, at least, of course, being statistical compounds, we have to take into account here, of course, individual variation, correct?
Sure. Yeah. I mean, it depends what kind of question you're asking. If you're asking sort of general questions about where in the brain these sorts of processes happen, there's a lot of evidence that for the most part, human brains are very similar. There are individual differences, but for certain questions, you can elide those differences and look at generalizations. And for other questions, you might really care about the individual differences. And, that is certainly something that neuroimaging allows you to do. The fact that it's not very high signal to noise makes it difficult, but, in early neuroimaging studies with PET, the signal to noise was even lower, and there were sort of health reasons to not do repeated studies with radioactive materials. So you couldn't really look at individual differences, but with fMRI, there's no health implications for repeated studies, and you can start getting enough signal in individuals to look at individual differences, and lots of people are starting to do that. So that's another, I think, useful tool for understanding more subtle aspects of neural processing and behavior in humans, because there are very few ways of looking at intact human cognitive functioning that we have available. So I think it's an indispensable and powerful tool, but it's not an easy tool to use, and it doesn't sort of wear its heart on its sleeve. You can't just easily look at the result of a study and say, oh, here's clearly the conclusion, now we can move on. There's no questions now to be asked. There are always more questions to be asked.
Sure. And you also do work specifically in neuroethics. So how does neuroscience intersect with ethics exactly? I mean, what questions does neuroscience bring to the table that are relevant in the context of ethics?
I think there are two general big kinds of questions that are kind of specific to neuroethics. One is neuroscience is developing rapidly technologically. We're coming up with new tools, new treatments. I'm talking very broadly about neuroscience, so I'm including things like CRISPR techniques on the nervous system, right? So there are lots of new powerful methods that we have available, and there are questions about the ethics of using those methods in humans or in animals that I think are important. And in that sense, I don't know that they're very different from general bioethics questions. But the other kind of question, and these actually intersect, is, you're talking about a body part that has a certain kind of privileged position with respect to the person and autonomy. So there are questions about what the ethical implications of changing or messing around with the part of you that might that many people think really is who you are. Do you change the person when you intervene with various kinds of therapies? Do you undermine their autonomy? Do you undermine their agency? And so those kinds of questions about agency, personal identity, those are a little different than what happens if you operate on somebody's left leg. And I think that is one of the things that makes neuroethics distinctive.
Mm-hmm. And when it comes to agency, particularly, how do you approach it? I mean, do you have, perhaps I would like to ask you, how do you define it? What does it mean exactly to have agency?
Oh, that's a big question.
I know.
I will, I think, avoid defining it. I don't know that we know how to define it, but I've been working on a project that's maybe trying to approach that in a sideways manner. So the question, the underlying kind of question that's driving this research is what kinds of effects do neural interventions have on human agency? And this is driven by these kind of neuroethical worries or questions about, the effects of being able to mess around in people's brains. So we have therapies for things like Parkinson's disease that are quite invasive and have the potential, at least, to interfere or change lots of aspects of brain functioning. And so even though the therapy itself seems to be very effective in combating the symptoms of Parkinson's disease, there are questions about what other things are happening, and are we tracking those things appropriately, and how do we value or evaluate those kinds of changes? So in this project, what I was interested in doing is sort of examining changes in agency, but in the absence of a good definition of agency. And I think there is no really good definition. We have a sort of working intuitive sense of agency as, being able, or at least human agency, being able to, set goals for oneself, follow those goals, so pursue them, evaluate them rationally, be self-driven in certain kinds of ways. And so the idea of this project is to come up with a way of sort of measuring aspects of agency in people before and after brain stimulation to see what kinds of changes there are. And so I don't think there is a sort of deductive method for figuring out exactly what agency is. I think what you want to do is use some sort of reflective equilibrium to try to come to identify aspects of human functioning that we think are important for agency, that seem to be involved in these general processes of, being autonomous, setting one's goals, being able to act rationally and pursuing those goals, etc. I include things like moral functioning, the kinds of functioning that we expect of fully developed, normally functioning, socially integrated human beings. And what we try to do in this study is to come up with questions that we can ask people about the way in which at least they view their own agentive functioning, and see whether we can see changes before and after neural stimulation. And so it's been actually a much more difficult project, both theoretically and practically / bureaucratically, than I had originally anticipated. Turns out to be very difficult to navigate clinical medicine. But what we have seen is that different kinds of neuropsychiatric problems have certain kinds of signatures in this agency space, where if somebody answers these questions, we have a pretty good ability to identify whether they have depression or OCD. And we're trying to get other kinds of clinical syndromes in there in order to see how fine-grained and telling these sets of questions are. So the idea ultimately would be, can you use this kind of metric to abstract away a picture of what agency is by looking at the kinds of variation that you see among different populations? And I don't know whether that's going to be possible yet, but.
Yeah. So let me ask you a specific question. When you mentioned the example of Parkinson's disease, and perhaps some interventions that are a little bit more invasive that are intended to treat the disease, I think, but it can have some adverse effects, I guess, particularly when it comes to things related or connected to agency. Perhaps it might damage, I'm imagining, some psychological mechanisms associated with agency. Just for the audience, perhaps to understand a little bit better what we're talking about here, could you give us some illustrative examples of what might be some of those risks? I mean, are there specific cognitive functions or mechanisms that would be at risk in this particular case?
Yeah, so I think the case that you're thinking about is deep brain stimulation, which is a method in which so after clinicians have tried to alleviate the symptoms of Parkinsonism with medication, if that doesn't work, sometimes they're driven to use deep brain stimulation, which is quite invasive, and so it's kind of a, maybe not last resort, but very late resort in treatment, where you have electrodes permanently implanted into areas deep in your brain, and they're attached to a stimulator that essentially sends electrical signals to that part of the brain to modulate activity. And for the most part, it's extremely effective in treating the symptoms, the motor symptoms, especially of Parkinsonism. But in some cases, people have reported changes that, in some cases, I think it's clearly adverse. In other cases, it's just changes, but still it's changes to things like personality or temperament or, rational behavior, et cetera. So some of the ones that are most frequent are certain kinds of compulsive behaviors. There are reports of, and a number of reports of people becoming much more prone to gambling or other kinds of compulsive behaviors than they were not stimulated. Or this actually also happens with L-DOPA treatment. So modulating this part of the brain seems to involve the reward system. And if you sort of ramp up the activity of the reward system, you can get things that look like compulsive behaviors. So, gambling or hypersexuality or other kinds of things that look compulsive. So, a really interesting illustration. I mean, this is almost the perfect philosophical thought experiment, although there's a case report that suggests that it's not just a thought experiment. So there was a man with Parkinson's disease that his motor function was so compromised by Parkinsonism that without deep brain stimulation, he was basically confined to bed, unable to move. But under deep brain stimulation, he became sort of psychotic and he had to be put in an institution. And so he basically had to make the choice between, having motor function or having rational cognitive function. And apparently in his case, that there was not a happy medium where he could have both things at the same time. And so, then you get questions about what do people really care about, and even more interesting philosophical questions about who gets to make the decision. So you can imagine a case in which the person who's bedridden wants to, not be, and so chooses to be psychotic. But what about, if the person who's psychotic makes a choice, is that a choice that you consider a competent choice? And if you think of these as two different people, there's a really question of which person would be able or would which person should be given priority if those choices are not stable. So I think that's maybe the extreme version of this kind of scenario, but I think that in general, if you're undergoing deep brain stimulation, there's always the possibility that there are going to be effects on other parts of the brain or behavior that are unanticipated, and the patients and the clinicians have to weigh the advantages of the improvement in the Parkinson's symptoms with the other kinds of changes. And sometimes the patients are, sort of recognize those changes and embrace them and feel like, this treatment has restored me to who I really am. And sometimes the patients, even though the treatments are effective, feel alienated by those changes and then have a real conflict about, whether they want to be this person that they are under stimulation, but feel inauthentic in some sort of way, or whether they want to actually just deal with the symptoms of their disease. So I think there are really significant neuroethical issues that patients undergoing different kinds of interventions face. And part of the goal of my project is to be able to characterize what those differences are in a way that can help patients make those kinds of decisions in an informed way.
Mm-hmm. But are you worried about questions regarding the, let's say, perhaps not exactly the legality, but if certain medical interventions, more or less invasive, applied to neurological conditions, should be permitted even to begin with? Because it's one thing, for example, for us to have a medical intervention where the doctors know the risks and benefits, and they inform the patients, and they make their own decisions with all of that in mind. But do you think that there might be particular cases where certain interventions, because of certain adverse side effects they might have, should be just outlawed altogether, or not even part of the medical system? I mean, should the decision always fall on the hands of the patients, regardless of the potential risks, or are there specific cases where you think that shouldn't even be on the table?
Well, I think historically there are examples of things that that I think maybe shouldn't be on the table, like lobotomy, where you're actually destroying a part of a person's brain in a way that's not reversible. And I think the nice thing about deep brain stimulation is it is reversible.
Mm-hmm.
In this, I mean, you still might have a little bit of damage from the surgery, but for the most part, the intervention itself, although it has risks of infection and things like that, there's not a lot of evidence of sort of widespread destruction of brain tissue. So you can turn off the stimulator, and that is a nice thing about the technique, because you can in a sense test it out and see whether the results are worth the changes. But yeah, certainly I think one can think of interventions that would be dramatic and irreversible, and I think that might be a reason not to go that way. And I think that there are things that are philosophically challenging, like interventions that are enhancements rather than treatments for disease.
Yes.
And to what extent should those be allowed? I think that there are many people who are inclined to embrace those kinds of changes. And there are questions about to what degree is that really should that be a matter of personal choice? I think that in the treatment domain, very much should be left up to personal choice. If people don't like the results of the treatment, they should be allowed to decline treatment. But should there be no regulation about enhancement? I'm a little less clear on that. On the other hand, there are lots of ways that our society pursues enhancement that we don't seem to have any problem with, that still are brain changes. I mean, we don't think that there's an ethical issue with sending our kids to the best universities. Well, what are professors doing? Well, they're, every time you learn, your brain is changing. So that's a kind of enhancement as well. And so there are certainly some kinds of enhancement that we're not troubled by. And so the tricky part is to understand why we are troubled by some kinds of enhancement, and whether we should be troubled, and if we are, what kinds of regulations should we put on those kinds of pursuits. So
yes, I've also addressed these questions in other interviews, like for example with Dr. Henry Greeley, where we talked about CRISPR and other genetic engineering techniques that certainly raise questions regarding even eugenics, biological inequality, and even at the extreme, I guess, we can get into unintended situations where it would risk, in this case regarding genetic engineering, our genetic pool, because we can't really predict the kinds of environments we will have to live in the future. And if we reduce our gene pool just to enhance ourselves genetically in certain aspects, like, I don't know, intelligence, personality, whatever it might be, then it could even pose an existential threat to our species, I think.
Yeah, I think that's a sort of doomsday version of it, but I agree that there are real issues there, and in some sense deeper issues than the kind of individual level changes that you get from the kinds of neural enhancement I've been talking about. I think part of the problem is, in those kinds of cases, you're not just making choices for yourself, but you're making choices for future people and future generations. And so that gives it a different dimension.
What about neuroethics applied to the court, or more specifically neuro law? Are you also interested in those kinds of questions? I mean, things regarding how neuroscience, neuroimaging, for example, might be used or misused in the court?
Yeah, so I have written about that as well. And in general, my take is rather deflationary. So I'm mostly concerned with the misuse of images, because I think it's complicated to understand the science, and the layperson and the lay judge is not really trained to understand the science. And I think it would be quite easy for someone to come in, flash a bunch of pictures on the screen, and give them an interpretation that's unwarranted scientifically, but conducive to the case that they're arguing for. So I'm concerned that there's scientific and neuroscientific literacy in the courtroom, and enough regulation that people are prevented from misusing the science. But more generally, I think it's not very often that neuroscience is relevant in the courtroom, and there've there've been where there's been talk about, well, neuroscience will show that we don't have free will, and then there won't be anything like moral responsibility, and we'll get rid of our system of justice. I don't think that that's correct on many levels. I don't think that any neuroscientific evidence that can be presented in the courtroom is going to show that free will doesn't exist. I do think that there may be cases in which the scientific evidence could lead to exculpation of people because of lack of capacity. I think that the science, though, is beholden to behavior. So I still think that behavior, sort of the old-fashioned psychological kinds of analyses are really the ones that are going to carry the day, or should be carrying the day in the courtroom. And the neuroscience might sort of nudge things a little bit one way or another, but I don't see neuroscience as the driver. And I think that there's a real misunderstanding among the public, and often beyond just the layperson, about the priority of these things. So people tend to put a lot more stock in the testimony of neuroscientists than they do psychologists, for instance, without understanding that the interpretation of the neuroscientific data is dependent upon behavior. And it's the expert on behavior, the psychologist, that really even allows the neuroscientist to get any traction on the interpretation of their results. And so if you're not going to trust the person who does behavior, you shouldn't be trusting the neuroscientist either. And I think that there's a real lack of understanding about the dependence of the neuroscience on the psychology. So yeah, so I don't know that I've ever thought that any piece of neuroscientist would, sort of radically change the way I evaluated a case in the law.
Mm-hmm. But do you think that questions regarding moral responsibility can be answered by scientists, and specifically neuroscientists, or do you think that those are questions that fall outside of the rubric of science?
Well, I think questions about moral responsibility are questions that depend on an entire social understanding and understanding of social norms. They tend to be more philosophical than neuroscientific. I think that there are times in which those things can intersect. But again, I don't, just as I was talking about the neuroscience and psychology, I don't think that you'll be able to look at a brain scan and say, this person is not morally responsible on the basis of that brain scan. You're going to get evidence from their behavior over a long period of time that will be much more probative than anything that you're going to see on a brain scan. So I think the neuroscience is much less direct in some sense than a good behavioral analysis would be.
Mm-hmm. And what about questions surrounding free will in general? Because ever since, at least in the context of neuroscience, ever since the Libet experiments, there's been people saying that it just proved once and for all that there's no free will at all. But there's also many people out there, including very prominent philosophers like Daniel Dennett, questioning that interpretation of the experiments. I'm not even sure what Libet himself said about the experiments, because sometimes it's easier to get access to what other people commented on them than what he himself said about them. But what do you think about it? Do you think that neuroscience has ever proven at all, or can prove that free will does not exist?
No, I very vociferously argue that it cannot show that, and it has never shown that. I think the Libet experiments are extremely misunderstood. Interpretations are completely wrong. The ones that suggest that he's demonstrated that we lack free will on many levels. The results that he got are exactly what you would expect to see if people are making decisions and their brains are involved in making those decisions. So in anything, any kind of naturalistic interpretation where your brain is involved in producing behavior, which I think most of us accept, you see exactly what you would expect to see when people are making decisions to, press the button, etc. And this idea that your brain decides before you do seems to be, completely undermined by looking at our understanding of decision making and what making decisions would show if you did the analysis that Libet did. So to my mind, there's absolutely no validity to any of those kinds of interpretations that suggest he's told us anything at all about free will. What he sees is what you would expect to see if people are deciding what to do. And that's what the task is asking them to do. It's asking them to decide to move. So I don't think that I have never seen any experiment at all that suggests to me that we don't have free will. There were neuroimaging experiments that were touted as also showing that we lack free will because they could get a tiny bit of predictive power over somebody's choice by sort of seconds before they make their decision by analyzing this neuroscience data. And again, if people's choices have any relation to their prior behavior, for instance, if you're asked to randomly make choices, then you're actually aware of what your past choices have been, and you're making your next choice in part on the basis of what you think randomness is. And so you have a record of your past behavior in mind as you're making your choice. And so that record itself is going to give you a tiny bit of predictive power over what your next choice is. If you've pressed the right button 5 times in a row and you're like, oh, well, if I'm supposed to be random, it's probably time to press the left button, right? That's going to give you a little predictive power over what you're going to do. And so the fact that there's a little bit of signal that can be exploited in these decoding studies to give you, slightly more than 50% ability to make predictions, I think that's just reflective of the fact that we do have memory and, certain kinds of intentions when we make decisions. And we also have stable preferences. So if you, tell me to pick between 2 flavors, if I have a preference between those flavors, that's going to affect my prediction. And anyone who knows me is going to be able to predict that I would pick, coffee ice cream over pistachio ice cream every single time. Does that mean I'm not picking freely? So I think that all of these reports of neuroscience undermining belief in free will, for the most part, shows that the neuroscientists are not understanding the problem. They are really oversimplifying it. I also don't think that there's any result in neuroscience that demonstrates that we are deterministic systems or that we're indeterministic systems. I think that neuroscience can't speak to that problem at all. And anyone who has argued differently has, again, misunderstood what it would take to show that something was or wasn't deterministic.
I have 2 or 3 more questions to ask you about that, not just about tackling the question of free will through a neuroscientific perspective, but perhaps adding other scientific domains to that. But please correct me if I'm wrong, but isn't it also the case that just from patterns of brain activity, even if we get, for example, the patterns of brain activity within the same person, and we know that whenever she performs a particular kind of behavior, the brain, certain regions of the brain activate in a particular pattern. I mean, that just by looking at the pattern, we can't really predict exactly the behavior that will be produced, because for the same pattern corresponds to different behaviors also in different contexts. I mean, is that correct? Because that's the idea I got from reading about this issue.
Yeah, I think that's true. And I part of that is that the pattern that you're seeing from any kind of technique that we have is partial information, right? You're in neuroimaging, you're averaging over millions of neurons in every voxel. In single cell recordings, you might be getting single cells, but you're not getting the rest of the cells that are involved in this network. And so you never know that what you're looking at is exactly the same, and subtle changes can lead to quite different behaviors. So I don't think we're ever in a position to make inferences of that sort. We just don't have the information that we need.
But okay, so you said that you don't think that at least anything that has been developed in neuroscience up till now would be able to completely solve the question of free will, if we have it or not. But what if we add other behavioral sciences, like, for example, Dr. Robert Sapolsky, in his book Behave, but also in other places, other mediums, he has a very strong position against the existence of free will, but his argument doesn't stem only from neuroscience, even though he's a neuroendocrinologist in training, but he goes through other areas of science, like evolutionary psychology, endocrinology, like the social context, that is things coming from sociology and anthropology, genetics. So he looks at different levels of explanation of behavior and different time scales. As he says in the book, he looks back 1 million years before the moment where the behavior is produced, 1 hour, 10 seconds, I mean, whatever. So he joins together as many sources of behavioral science as he can. Do you think with all of that, I mean, that is enough to tackle the question, and it is better than just neuroscience alone, or it's still not enough?
Well, I think it's still not enough, because I think he accepts a certain philosophical view about free will that many people do not accept. So there are views of free will in which free will is possible, even if the universe is deterministic. So all of the data that he talks about is data that might make you think that determinism is true. You know, so I mean, he's thinking more about biological determinism, but you know, the very strongest view is, you know, physical determinism, that the entire evolution of the universe is determined, right? And even if that's true, there are philosophical positions upon which what free will requires is just orthogonal to the question of determinism. And my view is one of those views, that that what free will requires are certain kinds of capacities and ways of exercising those capacities that are open to the right kind of system, even in a deterministic universe. And so I think even if you grant everything that Sapolsky says, there remains this big open question about the nature of free will that that he's not, you know, he's taking a stand on that question, but I think that there are very good arguments against that position.
But do you think that there are specific neurological conditions where we can say people lack free will, or at least do not have the same level of free will that normal, quote unquote, people have?
Yeah, so I think that that's really where we should be looking is what are the relevant capacities that what we're really interested in is less free will than moral responsibility. And what are the capacities that someone has to have? I think that those, you know, they're very tightly linked, the question of free will and the question of moral responsibility. And are there kinds of neurological disorders or brain damage of certain sorts that would impair those capacities sufficiently that we could say that that person did not act freely and is not morally responsible for their behavior? And I think there probably are conditions like that. But in order to make those kinds of distinctions, you really have to understand more what those capacities are, how you know, scaling of those capacities affects attributions of freedom, and what kinds of damage or dysfunction would significantly impair those capacities. And I think that that's really what the way that our legal system is structured is asking about capacities and making determinations on the basis of whether people, you know, have them and failed to exercise them or actually lack them. And that is a place where I think neuroscience could play a role in the law, but I don't think that it currently has that. You know, I don't think we're at the level where we know enough in order to really use the neuroscience.
And can free will exist without consciousness?
I think that's a great question that I don't know that I've thought my way through it entirely. And I think that again, the question is not well posed in those terms. So there are many kinds of things that you might mean by asking whether or by saying without consciousness. So you might think that if you know, if someone is entirely unconscious, they cannot act freely, right? So like the state of being aware of something might be important for any attribution of free will, maybe because the capacities that you need to be free require consciousness themselves, right? So that's possible. But do I need to be, so this goes back to some of the Libet stuff. The implication of the classic Libet interpretation of the study is that you're not aware of your intention, right?
Mm-hmm.
Your intentions aren't conscious, but they're already you're already engaged in preparing for action. And I think the idea that your intentions have to be conscious for you to act freely is a mistaken idea. In fact, I think we're not typically conscious of our intentions at all, unless we, sort of turn inwards on ourselves and ask ourselves, am I conscious of an intention now? But that isn't something that we typically do. So if you're driving down the road and you're approaching a traffic light and it turns orange, and you have to decide, do I step on the brake or do I step on the gas? You are conscious of the traffic light turning orange, and you might be conscious that you have to make a decision, but you're not typically aware of your intention to step on the brake or the gas. You consciously step on the brake or the gas. That is, you're conscious while you're doing it. You're conscious of the world around you. And so in the Libet task, they're not asking you to be conscious of something in the outside world. They're asking you to turn your consciousness inward. And it's just not something we do normally. It's not surprising that people find this task really weird and difficult, and they're not even sure that they're doing it right, because we're not typically conscious of our intentions in that way. We just consciously intend things, and they do consciously intend to move their finger. So the question that's being asked in that study is the wrong kind of question to ask about, the relationship between awareness and free will.
Mm-hmm. But this is really perhaps one of the biggest issues here, right? Because I mean, many people come from the position where if what leads to our behavior occurs mostly subconsciously, and we don't really have access to the motivations, the reasons, the causes behind it, then we don't have free will. That's usually the way many people, scientists, some philosophers, address the issue. Correct.
That's right. And I think that probably the best challenges to free will are about unconscious influences on our decision making.
Mm-hmm.
And that's not what Libet studies look at.
Mm-hmm.
So I don't think we are ever aware of the causes of our action in the sense of the neural basis of our actions. I mean, for centuries, nobody even knew that the brain was the thing that governed action. Yeah. And we never thought, oh, they were never responsible for anything because they didn't know that, right? So that seems to be a totally irrelevant thing. We don't need to know the nature of our brain states in order to have free will and be conscious. I think that there are real questions about the influence of biases in our decision making that you can imagine under certain kinds of conditions that I think it's not clear that they obtain very often. If those biases are so strong that they could override our reasons and our preferences, then I would be inclined to say that might be a situation in which somebody didn't act freely. And I think that also becoming aware of them gives us a certain added power, right? So there may be unconscious influences on our decision making. There are real questions about how strong they are. In cases where you have no reason to do one thing over another, the fact that some small impetus in one direction or another might affect your decision making doesn't seem to me to be a problem, because if you have no reason to choose one or the other anyway, why not let whatever, wherever the winds blow, help you choose? If you're making a consequential decision and your all of your rational processes are overridden by something that you're unconscious of, I think that's a real problem, but it's very rare that seems to be the case. So I think that it's important when you're deliberating to be aware of your reasons, to be aware of your goal, what the question is that you're deliberating about. If we were unconscious of all of those things, I would also have questions about free will, but we're typically not unconscious of all of those things. And then the real question is the kinds of influences that we're not conscious of, what actual, how strong are they? How often do they override our deliberation? And I guess I've not seen lots of evidence that that's the case, and it certainly doesn't seem to be endemic. There may be certain situations in which those kinds of influences are strong enough to worry us, but that certainly doesn't undermine my belief in general free will.
Mm-hmm. Do you think that the idea that Daniel Dennett put forth of free want can be helpful here? I mean, not really that we have free will, but more that we have the ability to decide to abort particular decisions, let's say.
Yeah, I mean, it's helpful, I think, just maybe to call attention to the fact that inhibition is an important aspect of free will. In the context of the Libet studies, I don't think that it's helpful at all, because free won't is just another decision that's subject to exactly the same kinds of neural timing issues that Libet identified. I don't think it's a problem, because I don't think that the things that he identified are a problem. But if you bought into the Libet paradigm and thought you could save free will with free won't, I think that you'd be in trouble, because you would find exactly the same kind of relationship between the neural signals for deciding to abort that you see in the signals to decide to move. So it's not a advantage for Libet at all. But I think that the idea of being able to stop ourselves from doing something is an important aspect of what it is to be an agent with free will. And you might think that if there were certain kinds of neurological issues that really prevented people from doing that, from inhibiting behavior, then those would be candidates for things that would exculpate people from moral responsibility in certain kinds of cases. And again, I think the law, I mean, I'm not sure that the way the law is written currently is adequate, but we have that implicitly in the law with things like crimes of passion, right? We're just so emotionally hot-headed that you couldn't stop yourself from doing something terrible. And that's supposed to be a kind of an excuse. And I think it builds in this kind of notion that if you lack the capacity in the moment, then there's a certain kind of exculpation.
And also perhaps that distinction that is usually established between a crime that is committed in the heat of the moment impulsively versus a crime that is deliberately planned. right?
Yeah, right. Yeah. So I think that actually the, sort of our common laws have a lot of implicit adherence to this kind of capacitarian notion of freedom and responsibility that I think is the right one to use, and that there are times in which those capacities are, really impaired, and that should be given consideration. I mean, I personally don't think that the crime of passion excuse really is that much of an excuse. I think that there are certain things that a responsible person should be able to prevent themselves from doing, even in the heat of the moment. But it does suggest that inhibition is an important aspect of freedom.
Great. So just one last question then before we go. Would you like to mention what kinds of questions and topics you're working on at the moment?
So at the moment, the agency stuff that we talked about briefly is sort of front and center. I have a grant that's going to be wrapping up in the next year, and still quite a bit of work to do on that. And I'm quite interested in questions about whether neuroscience can give us a handle on things like animal consciousness. I'm interested in pursuing further, given sort of the insight, or, well, the question is whether it's really giving us insight, but the developments in artificial intelligence and the way in which they're being employed in neuroscience, I think is something that I'd like to spend more time looking at, to see to what degree insights from deep learning can tell us about neural representation, about interpretation of neuroimages, things like that. So those are things that I'm looking forward to, and as soon as I catch up on all the things that I'm behind on, maybe I'll be able to turn my attention to that. But for now,
by the way, the animal consciousness bit, are you also interested in connecting it in any way to animal ethics, or are you just interested in the more philosophy of mind side of things, let's say?
Oh, I think the animal ethics stuff has always been a motivating factor, although it's not something that I've spent much time on. So I think that's sort of in the background. But I would say the primary driver is, philosophy of mind type questions. So I actually wrote my dissertation on, or the underlying question of my dissertation, I should say, was about thought without language. And it's still something that I'm really interested in and have wanted to get back to. So, yeah.
Great. So, and where can people find you and your work on the internet?
Now, that's a good question. I currently have actually, I'm not sure that my website is up to date. Dartmouth did a reboot of its system, and I'm not sure that I ever reposted my old website, and I may not be there for that much longer anyway. So I think maybe just Google my name, and I will show up. There are not many Adina Roskies around, and I do have to put up a website again.
Okay, so I will be definitely leaving some links to your work in the description box of this interview. And Dr. Roskies, thank you again so much for taking the time to come on the show. It's been a real pleasure to talk to you.
Yeah, it's been a lot of fun. Thanks for your great questions.
Hi everybody, thank you for watching this interview until the end. If you like what I'm doing and to keep the channel sustainable, please consider supporting me on Patreon or PayPal. You can find all of the links in the description box of this interview. And if you like this interview, please share it, leave a like and hit the subscription button. This show is brought to you by Enlights Learning and Development Done Differently. Check their website at enlights.com. I would also like to give a huge thank you to my main patrons and PayPal supporters, Per Erga Larsen, Jerry Mueller, Hans Fredrik Sunda, Bernardo Seixas, Herbert Gintis, Olaf Alex, Jonathan Visser, Adam Kessel, Matthew Whittingboard, Arno Wolf, Tim Hollacy, Eric Alenia, John Connors, Philip Force Connolly, Dan Demetri, Robert Windager, Rui Inácio, Zup, Marco Neves, Colin Holbrook, Simon Columbus, Phil Kavanagh, Jorge Spinha, Michael Stormir, Samuel Andreev, Francis Ford, Tiago Nunes, Alexander Dunbauer, Fergal Cusson, Hal Herzog, Nuno Machado, Jonathan Librant, João Linhares, Stanton T, Samuel Correa, Eric Hines, Mark Smith, João Eira, Tom Hummel, Sardas France, David Sloan Wilson, Yacila Dez Araújo, Romain Roach, Diego Londonho Correa, Yannick Punter, Adana Rusmani, Charlotte Bliss, Nicole Barbaro, Adam Hunt, Pavel Ostazewski, Nelek Bach, Guy Madison, Gary G. Hellman, Saima Fzal, Adrian Yegi, Nick Golden, Paulo Tolentino, João Barbosa, Julian Price, Edward Hall, Edin Bronner, Douglas Fry, Franca Bortolotti, Gabriel Pons Cortez, Ursula Litske, Scott, Zachary Fish, Tim Duffy, Sonny Smith, John Wiseman, Morten Eichland, Dr. Bird, Daniel Friedman, William Buckner, Mau Maria, Paul George Arnaud, Luke Gloaki, Georgios Theophanos, Chris Williamson, Peter Woloslin, David Williams, Ruth Towell, Diogo Costa, Anton Erickson, Charles Morey, Alex Shaw, Amaury Martinez, Coralie Chevalier, Pedro Bonilla, Ziegler, João Barbosa, Bangalore Atheists, Larry D. Lee Jr., Old Herringbone, Starry, Michael Bailey, Dan Spurbert, and Robert Grassis. A special thanks to my producers Isar Webber, Jim Frank, Lucas Stafiniak, Tom Vanagdam, Bernard Ugni, Curtis Dixon, Benedict Mueller, Vega Guidi, Thomas Trumbull, Catherine and Patrick Tobin, John Carlo Montenegro, Robert Lewis, and Al Nick Ortiz, and to my executive producers Michel Rugieski, Matthew Lavender, Sergio Codreanu, and Bogdan Kanivets. Thank you for all.